whole square. So now we have this result. What we have to do further with the help of this result, now take the square root of both the sides. When we take the square root of both the sides, in the right hand side this square root basically cancel out through this square and we get only 1 plus u prime v upon c square upon 1 minus u prime v upon c square. If you remember, this ratio of 1 plus u prime v upon c square upon 1 minus u prime v square upon c square, it was m1 upon m2. In the beginning we have seen this m1 upon m2 is equal to 1 plus u prime v upon c square upon 1 minus u prime v upon c square. So instead of this, one can put the value of these m1 and m2. So we are just putting this value instead of this ratio. Now we are putting the value of m1 and m2. So now the left hand side, that is square root 1 minus u2 square upon c square upon square root 1 minus u1 square upon c square is equal to m1 upon m2. And further simplification, one can show that m1 square root 1 minus u1 square upon c square is equal to m2 square root 1 minus u2 square upon c square. So further, from this equation it is clear that the left hand side m1 and the right hand side, this is independent from one another. This result may be correct only if each is a constant, as we have seen earlier in a gaseous cases P1 V1 is equal to P2 V2, like this one. So similarly this left hand side and right hand side both are independent to each other and it should be equal to a constant. Suppose that constant is m0. So one can write here m1 is square root 1 minus u1 square upon c square is equal to m0, and this is also true for this m2. Second case 1 minus u2 square upon c square. So now if m0 is the rest mass where m0 is the rest mass, so m1 is equal to m0 upon square root 1 minus u1 square upon c square. And now further we conclude that if m0 be the rest mass of the body, then its mass m when it moves at speed v will be m1 is equal to m and u1 is equal to v. Then this equation becomes m is equal to m0 upon square root 1 minus v square upon c square, and this is the required result, where m is the mass observed of the particle according to the O observer. M mass, this is the formula left hand side according to this one. m0 is the rest mass. The rest mass basically is kept into the S prime frame, that is a moving frame, and m is mass that basically appear to this observer. So from this relation one can see that when v is equal to c, that time m becomes infinite. So this is the relativistic mass. M is equal to m naught upon square root 1 minus v square upon c square. And I summarize it again, that from where we have taken the idea of relativistic mass. The origin we have considered a moving frame. With this simplest case, this was the physical situation. In elastic collision we have considered, and here we have considered the same mass of these two balls and same speed. Collision was inelastic. Inelastic means the kinetic energy before collision and after collision will be different. Then after we convert this into a coordinate system, that basically a frame of reference S prime and S. S prime frame is a moving frame, moving with respect to S with this speed v, which is relative to this one, and these are the two balls in S prime frame. So this was the idea of relativistic mass, and m is equal to m naught is upon square root 1 minus v square upon c square is that formula.